Good evening and welcome to this lecture on India's ancient architecture and sacred geometry. So it's a bit of an intriguing title, but I think you will realize what I mean as we progress. I would just before I start, I'd like to remind you that there are two more lectures this week. One is on Thursday and the other on Friday. So Thursday will be about Ayodhya and the chronology of Ayodhya as far back in the past as we can trace it. We're stopping at somewhere in the beginning of the 20th century to avoid very recent events. This will be on Thursday, and on Friday we will have a look at educational systems in ancient India. What kind of education was there, and how did it work, and what kind of evidence do we have? So let me start with this beautiful temple, which we will visit briefly during the course of the talk. And some of you would have recognized the Kailash temple at Ellora, which is actually unique in India. And you see these, I don't know, unfortunately the contrast is not very good, but this is a tourist here. You see this little white dot? Gives you the scale. It's just colossal. And what is unique about this temple, of course it does exist on smaller scales from a technological point of view, is that this is not a construction, this is a sculpture. The whole hillside has been sculpted, and what remains is this, you know. So 100,000 tons approximately of rock was removed, chipped away by generations of sculptors, and the size is just awe-inspiring. So we will revisit it briefly. But let me start at the beginning. So once again, we're back to the Indus civilization. And because I'm trying to find some patterns in India's architecture, patterns of geometry and certain concepts which we'll come to, there is something strange going on, unexpected in the Indus civilization. Completely unexpected because it is what archaeologists call a non-utilitarian feature. It serves no practical purpose whatsoever, and this is the feature, that precise proportions are imposed on areas of the city. This is the Acropolis, the upper city of Mohenjo-daro, and it's exactly twice as long as it is wide, approximately 400 meters by 200 meters. And well, archaeologists, you know, in vogue, and plus the fact that this is exact north-south axis. So there is a desire to align the city to the cardinal directions, which, you know, is not the case of many. I don't know whether Kanpur today is aligned to the cardinal directions, I doubt. And then there is a sense of order. And what exactly does it consist in? We'll have a look. And this order actually is attached to the notion of authority, in the sense that Harappan civilization does not come up with impressive palaces for the rulers, as you have in Egypt, for example, where the palace stands out in many ancient Egyptian cities. So you know that the pharaoh must have lived there, because you know the message of architecture is clear. Here there is no such clear message. Rather, it is this sense of order which seems to indicate, and this is especially the upper city of Mohenjo-daro, where the rulers definitely must have lived somewhere in one of these buildings. But when you look at all these buildings one by one, this is what happens. Every one of those major structures, so whether it is the Great Bath, famous Great Bath, I'm not showing you all the structures photographically in detail because it would take us too far. There's a huge complex of rooms which measures 23 meters by 69, so that is exactly a proportion of 3:1. Granary, so-called granary, there are some doubts nowadays whether it was actually a granary. Proportions are exactly 3:2. We find 7:5. We find 7:6, etc. And it is very strange because, in fact, it doesn't seem to have any particular practical purpose. So why choose always certain simple fractions, simple ratios to be implemented on the ground, which actually complicates the job of the architect and the job of the builder? So let us proceed. Then this is in the lower town of Mohenjo-daro, we find a building where the ratio, the proportions are almost exactly 1.25, that is to say 5 to 4. And we're going to find this 5 to 4 in a lot of unexpected places, as you will see. This is the largest building in the entire Harappan civilization, measures a little over 50 meters by a little over 40, so it's huge. And the beauty is that once again, nobody really knows what it was used for. What function was it? It was earlier called a granary, but there have been more recent suggestions that it might have been some kind of an assembly hall where people were meeting, but basically we don't know. But what we do know is that if you calculate the dimensions, you get again 1.25. So something is going on. And what is it? We'll explore. This is Kalibangan in Rajasthan, on the edge of on the bank of the Ghaggar or Saraswati river, right on the bank. And it has, like Mohenjo-daro, it has, and like several other Harappan cities, it has an upper city here, proportions 1 to 2 like at Mohenjo-daro, the same, and the lower town proportions 2 to 3. So what exactly is the idea is what we have to try to understand. This is Lothal near Ahmedabad. It's of course an artistic recreation of the site, which certainly must have looked very different, but it's an approximation. And here, when you look at the plan and you take the middle point here, you find 5 to 4 again. If you take this middle point, of course, this side is slanted. You have to take the center for this. And this is the famous dockyard, which you can see here again, and the proportions are exactly 6 to 1. So it looks as if these people did not believe in constructing structures just randomly and let them, let them be whatever they might be. They impose certain proportions. And the most extraordinary example is Dholavira, which I've referred to several times earlier. It's a large city, for those who might not have followed, large city in the run of Kutch, on a small island in what is today a very arid region, where there is no city nowadays, no town, no big village either, just hamlets scattered on this island. And here you find that the city has made basically 3 divisions, not 2 as earlier, but 3. This is the upper city here, consisting of 2 structures, which the archaeologist Dr. R.S. Bisht, he gave certain names, which are, just slightly arbitrary. But this is the bailey, this is the castle, because of the very thick fortifications reaching up to 19 meters in thickness, those walls. Then you have a ceremonial ground, you have a middle town where most inhabitants might have lived, some also in this corner of the lower town, and you have the complete enclosure, which represents an area of 48 hectares. But if you look at the dimensions of the castle, they are exactly, very, very precisely 5 to 4, both inside and outside, inner and outer dimensions. If you look at the overall city, then then all doubts vanish, because over a length of what is 771 meters and an irregular terrain in addition, you have a ratio of 5 to 4 almost perfect. The margin of error is 0.01%, something like that. So this is clearly a deliberate intention, especially the repetition of that. Then you have 2 ratios of 9 to 4. This width of the castle to the width of the middle town, ratio 9 to 4, that is 225. And from here also to here, 9 to 4. Something is going on. And this is the ceremonial ground, exactly 6 to 1, which is the ratio of the dockyard at Lothal, as we saw. And 7 to 6 is the proportion of the overall middle town. And there are many more. In fact, these are some of them. You see here the margins of error. The average margin of error is actually 0.6%, less than 1% when you take the measurements. So there is an intention. And in fact, it goes on, because if you look at now the reservoirs, you might remember that Dholavira was sustainable in the 3rd millennium BC only because the Harappans there had built enormous systems of reservoirs which were interconnected. I will briefly touch upon this in a future talk. And this largest reservoir, which measures actually 73 meters in length, 73 meters, the ratio is 5 to 2. So 2.5, and very precisely. So there is, of course, a desire to implement those ratios. 7 to 2, this is the famous rock cut. This is cut in the rock, in the sheer rock. 7 to 2 for the major reservoir, 11 to 4 for the secondary reservoir at the bottom. And so on. It goes on. But if you plot, this is a sketch I prepared, where I took all simple fractions. Simple in the sense, of course, mathematically you can always find a fraction anywhere if you want, but they may not be simple. They may be 115 by 37 or something. You will have to, look for all simple fractions systematically, and you find that every one of them there is a Harappan structure somewhere in one of the settlements. Some are far away, which will take it. So there is an intention, and clearly they are trying to tell us something. Let us leave the Harappan world for a while and go to the Vedas. And some of the late Vedic literature, like the Brahmanas, actually contains certain interesting concepts, which is one of which is the addition of a fraction to the unit. So unit is 1, and then you add something. And the procedure is described, and I'll give a later example. For example, we are told that 1/4 can be added to 1, so that gives us 5/4. But you can also add 1 plus 1 plus 5/4, so we get the 9/4 we are getting at Dholavira. And this addition of the unity is something which is expressed in many ways. For example, 21 is said to be the number symbolizing the human body. Why? Well, because we have 20 fingers. Now, 20 fingers, but why the 1? Because the 1 stands for the body itself. So you have the 20 fingers plus the body itself, that is the unit. And this gives you the totality. 7 is the number for space. Why? Because you have 4 cardinal directions. Then you have the direction above, direction below. So that is 6. Plus space itself, the unit. So that makes 7. So this is the kind of hints we get in the Vedic literature. And the fact that there is an insistence on repeating certain fractions, certain motifs, like 1 plus 1 4, 1 plus 1 plus 1 4, etc. So this is known technically as recursion, and we are going to see it shortly in classical Indian architecture. But before I move to that, I want to show you this surprising quotation by Varaha Mihira, who lived in the 6th century AD. And in his Brihat Samhita, which is a kind of encyclopedia of those times, there are some chapters on architecture, and there he lays down precise proportions to be followed. Now why? Because now we have a text, we have literature that explains to us. The Harappans are mute. They don't explain anything to us. But Varaha Mihira says that these are auspicious proportions. So if you apply those ratios to your buildings, structures, you will have an auspicious result. For example, he says, the length of a king's palace is greater than the breadth by a quarter. Now formulate that mathematically, and you get the 5 to 4 that we have seen for the castle at Dholavira. And he says here the king's palace. So it's quite interesting. Then he says the length of the house of a commander-in-chief, the Senapati, exceeds the width by 1/6. So 1 plus 1/6 is, of course, 7/6, which was the proportions of the middle town in Dholavira. There seems to be a continuity. And in fact, I have prepared in some papers much more evidence. But let me just give you one example. If you take a classic text of Hindu architecture, like the Manasara. Manasara is a text evolved in South India, but based basically in North Indian canons. It dates something like 11th, 12th century AD, when a lot of such technical texts were redacted. And you see how it explains. He says the length of the mansion to be built, if you want to build a house, a big house, this is what you do. You should be ascertained by commencing with its breadth, and then you increase, you create a length which is equal to the breadth plus a fraction of it. So the unit, again, this is the Vedic pattern, the unit plus a fraction of the unit. So it says you can increase by 1/4, that of course gives us 5 to 4, by 1/2, 3/2, by 3/4, or you can make it twice, or you can make it greater than twice by 1/4. We are getting our 9/4. You can add 1/2 or 3/4, or finally you can make it 3 times. And if you take all these proportions except this 7/4, which I could not trace at Dholavira, but it is available at other Harappan sites, not at Dholavira. But at Dholavira, all the other fractions mentioned here are available. So there seems to be, I'm not saying of course that the Dholaviran architects or town planners were, had already evolved such an elaborate concept of architecture. No, of course not. This is much, much later. There's a difference of something like 3,500 years between the two, between the top and the bottom. But there seems to be a similarity in the concept, because otherwise why should we be getting all these fractions so systematically in a single city? If you look at the Vedic sacrifice, and we will come back to the Vedic sacrifice in a few minutes, this is in fact the original Mahavedi, that is to say the sacrificial ground where the fire sacrifice is going to take place actually at this altar here, which symbolizes the earth. See, it's round, and the husband, wife, and priest are going to sit, all three of them, around this altar. Then there's another altar here which symbolizes the sky, the heavens. It is square because of the 4 cardinal points. And this is the in-between altar, Antaravedi. Antaravedi is what is in between the earth and the sky. So that's the path of the moon and the stars. Anyway, we have a cosmic background, but this is the entire sacrificial ground where there are many other altars. It's very complicated. But I just want to show you, this is the eastern direction, which is the holiest in ancient India, of course, because of the sunrise. And here you have a certain dimension. I'm expressing it in a certain unit, the prakrama, which is mentioned in the Shatapatha Brahmana. And but then, strangely, we start from here, and we might have expected a square or rectangle. Instead of that, we have a trapezoid. And this trapezoid, to me, symbolizes the increase that this sacrifice is going to create, because the sacrifice is always for a gain, either material gain if you take it very materially, or a spiritual gain if you take it at another level. So this is what this represents. But look at the proportion. It is 30/24 and it's 1.25. So we are getting the same 5:4 here again that we have already seen at quite a few places. Anyway, we'll proceed and we'll come back to this 5:4. Then we move in the first millennium BC to a class of literature which is called the Shulva Sutras. And the Shulva Sutras are basically the first text of geometry in India. The date is a bit approximative. This is roughly the date, 8th to 6th century BC. There are 4 major authors, Bodhayana, Apashtamba, and 2 more. And they basically give geometric rules for the construction of altars. They are not exactly as we just saw. First of all, there's a philosophy behind that, which is quite explicit, that the altar represents the whole universe. They want basically to replicate the original sacrifice of Prajapati, the god who in the Veda, his body becomes the various parts of this universe. And therefore, they want that any sacrifice should be addressed to the universe. But it's not very convenient at a practical level. So what you do is you shrink the universe to the scale of an altar. So there's an equivalence between macrocosm and microcosm, which is our scale. And the human body, very interestingly, is, we're going to find all this in classical temple architecture in a few minutes, is the unit which is the base of all calculations. And a Purusha, at the time of the Shulva Sutras, a Purusha is this unit. This is the Purusha, a man with his arm upraised. Later on in classical India, the Purusha will be limited to this. I mean, that's another topic. And so this is basically, all sacrifice has to repeat the original sacrifice that created this world, this universe. And the philosophy is that all of life is, a yajna, an offering. So scholars have spoken of the ritual origin for this reason of Indian geometry, and it is very true that it all started from this desire to construct complex altars like this one in a way that follows certain rules. This is the Kurmachiti, the tortoise altar, where actually each altar has 5 layers. So this is the first layer. Why 5 layers? Because the bottommost layer, don't forget this is the universe. You're actually having the universe in front of you. So the bottommost layer is the earth. And the highest layer is the heavens. And in between there are 3 intermediary worlds. So we have 5 layers. Each layer has 200 bricks, 1,000 bricks to build the altar, but they wanted to make it a little complicated. You're not allowed to use the same shapes of bricks from one layer to the next. All the shapes have to change. And you can see that it is going to be intricate because you can see that there are here alone 6 types of bricks. And but then there is a constraint that you can change the shape of your altar, but you cannot change its area. Now I'm going to show you a couple of other shapes. For example, where the square is an accepted shape of an altar. The circle, which is called Ratachakrachiti, is also an accepted shape, and I'll show you 1 or 2 more. And this area has to be 7.5 square purushas. That is to say, this unit which I showed you. So this is now you can see the complication we are getting into when you want to change from one shape of an altar, say from this one to a circle. All your brick shapes are changing, yet you have to ensure that the total area remains the same. So this is what led to very complex transformation of figures. They were expressing geometric procedures, for example, to change a square into a rectangle of exactly the same area, or a square into a triangle and vice versa, or a square into a square of twice the area, and so on. And also, of course, what became, in medieval Europe, the eternal problem of the squaring of the circle and the circulature of the square. That is to say, how do you transform, geometrically speaking, a square into a circle and vice versa? Of course, this one was approximate. It is approximate because pi does not, the nature of pi, which is transcendental, does not allow you to have a perfect geometrical procedure to change a square into a circle. Whereas a square into a rectangle, you can have an exact geometric procedure. So this is what Shulba Sutras are about, and this is another shape, complex, same 5 layers, 200 bricks each, and again, every layer, I'm showing you only one, I think this is the bottommost layer, will have different shapes of bricks. So this is really the birth of geometry in India, and this is going to be amplified upon by all classical mathematicians something like 1,000 years later than the Shulba Sutras. So I just wanted to show you the concepts behind those altars, and we have actually one piece of evidence from Uttarkashi, not very far from here, in Uttarakhand, where a huge altar was excavated at Purola. This altar measures 24 by 18 meters. It is actually about twice as large as what the Shulba Sutras actually prescribe. So it is not an exact implementation of the Shulba Sutras, but then we can see that this falcon altar was actually constructed at least in a few places. The ratio of this one, of course, is exactly 4:3. So there's always a ratio. There's always some auspicious proportion. Now, this is the background which slowly evolves into classical Hindu architecture. I mean, there is, of course, no time to document all the linkages. It's quite a slow and complex evolution, because now we are jumping a whole millennium between the Shulba Sutras and the beginning of classical Hindu and Buddhist and Jain architecture, because the 3 architectures are basically the same. There are minor variations, more in the sculptures, in the decoration, but actually the basic principles of the architecture are the same with the 3 religions. So we come now to one of the oldest living temples. Just as an illustration, it is 50 kilometers from here at Bhitargaon, and this is from the Gupta era. And of course, the temple must have been much bigger than this structure, but this is what is left. Most temples in North India have vanished for various reasons. Very few survive, but I'll show you one or two more. Now, the thing which struck British and European Indologists when in the 19th century they started describing this temple and trying to make sense of Hindu architecture, Indian architecture, is the fact that there seems to be some uncontrolled exuberance, uncontrolled what some of them actually called chaos. That they found that there was no, if you compare to let us say the cathedrals of Europe, which are so symmetrical, so orderly, and so on. Here, there's something which disturbed them, and actually, some of them, were very scathing about. I could have given a quote or two about this apparent chaos. This is from the Meenakshi temple in South India. Of course, it's an extreme example where every square inch of this gopuram is sculpted. No space is left free. And you have basically you have cosmic scenes like the churning of the ocean here. This is the you can see the rope here, and no space is left free. So the question is, of course, this is a caricature because there is still an overall sense of harmony. So how did they manage to instill this sense of harmony is what I want to now spend a little time on. And in fact, before I do so, this notion of chaos is actually very explicit in Indian architecture. And this is the chaos. This animal, which is a mythical composite animal called Makara, but it is not just a crocodile. It has sometimes the head of an elephant or the trunk, feet of various animals, sometimes the tail of a fish, sometimes tail of a peacock. Anyway, it's a composite animal, and it explicitly, in the classical text, it explicitly means chaos. That is to say, it is a period where the universe is reabsorbed. It has been destroyed. It has been, it is pralaya. It is pralaya. Actually, this animal symbolizes pralaya, and you have this arch, this beautiful arch, which represents, at the top of it, you have the kirti, the crown, kirtimukha, the crown, which represents the universe in its created form. So you have a cycle from chaos, pralaya, to creation, and back to chaos. So the classical Indian architects were very conscious of this notion of chaos, and they were looking for ways to impart some order in this chaos. Now, there were many ways, and I'm going to detail a few. One, as far as the statues are concerned, is the science known as iconometry. Iconometry, that is to say the measurements of icons, of images, is a very elaborate technical field, and there are texts and texts about that, which prescribe how images of particular gods. So you have the major gods, for example, they may have 120 angula. Angula is a unit which is at the base of all these measurements. Sometimes in ancient India it was said to be the width of the middle finger, but sometimes it evolves into the length of this phalanx. And then there is the handspan. So the handspan is this. It is called vitasti in Sanskrit. This is the handspan, and it is actually 12 angulas. You can measure with your own dimensions. You will find that it fits. So this is the basic unit which all statues use. And depending on whether you're dealing with a major god, minor god, male, female, it becomes very intricate. You will have various dimensions dictated, dimensions and proportions. So, for example, here, this is the typical where the body is divided in classical Indian sculpture. 7.5 vitasti, You can multiply by 12 to get the number of angulas, and this represents the whole human body. This is called talamana. Now, tala is a term we are used to in classical Indian music. You know, in Hindustani music, what is tala? It is the rhythm, the beat. But there is also a rhythm and a beat here in statues also, though we may not perceive it if we look at them in an untrained manner. We don't pay attention. But this is extremely rigorous in all these temple sculptures. Now, there are other concepts at work when we look at the monuments themselves. One is that actually there are two major symbolisms at work. One is vertical and the other is horizontal, as I call them. This is my own terminology, in fact. And the vertical symbolism, you can see it here at Prambanan, which we visited earlier in Indonesia. This is one very large complex of Hindu temples. One is for Shiva, Brahma and Vishnu. This one is Shiva. And it gives us a good model to understand the vertical symbolism. What's going on here is that you have a certain foundation. You see, this is it. And actually the entire temple is assimilated to a cosmic human being, a Mahapurusha, or sometimes, as you will see, he is called Vastu Purusha also. And this cosmic being is actually what the temple stands for. So it's actually patterned on the human body. The temple is patterned on the human body, but it is also a symbol for the cosmic being, so for the universe, in other words. So we have all these equivalences at work. So you have here the feet of this cosmic body. Then up to the top of the Garbhagriha, you have the main body, and this is the head or the shikhar of the temple and of this cosmic being. But in addition, there is a cosmic equivalence where the feet are equated to the earth and the body is equated to Bhuvaloka, which is the intermediary world, whereas the head is equated to Swarloka, or the heavens. So, in other words, vertically speaking, the temple is again a miniature representation of the universe, because you have all those three worlds. This, of course, is borrowed from the philosophy of the Shulba Sutras 1,000 years earlier, and it is also patterned on a human body. So we have many equivalences at work. Then there is what I call the horizontal symbolism, and I'm taking the example of the Brihadishwa, or big temple of Tanjavur, magnificent Chola temple, which recently celebrated its 1,000-year anniversary. That was 2-3 years ago, built by Raja Chola. Now, if you look at the plan, this is actually a very good example of the various components. I'm not going into intricate details about the different styles. This is the so-called Dravidian or South Indian style of temple architecture. In the north, we'll see a few examples. Things are a bit different, but basically the concepts are the same. You have a total enclosure, and there is some kind of a gopura, which in North India is often much more modest, generally much more modest, and it bears different names. In fact, it often bears the name of Tohana, which is borrowed from Buddhist architecture. And then you have various mandapams, various areas where, for example, in this one, there is Nandi facing the great linga, exactly in the alignment. Then you have two mandapa, actually, which are halls where a lot of activities are allowed, such as, religious discourses, dances, all kinds of cultural activities, music, of course, performing arts, basically. And then as you continue this travel, you come to an antechamber to the Garbhagriha. This is called Antarana, of course. That means basically in between. So this is usually very small, but in some temples it happens to be larger. And then you have the Garbhagriha, or the Sanctum Sanctorum, above which the Shikhar, which in South India is called Vimana, is located, is erected. So this is the basic sketch, but you can see that there's a tremendous amount of geometry at work. Because look at all these circles, how all these structures are inscribed in certain circles. You see the edge of this square, for example, coincides with this circle, and here this division between the two mandapa is another circle that will coincide with this alignment of this minor temple, which, if I remember well, is a temple to Kartikeya, and so on. So there is, and then of course this major division between two squares, you see, so 1 plus 1, this is 2 by 1 basically, and the diagonals always point to either the Garbhagriha here or the Nandi image there. So there's a lot of planning, thinking of a geometric nature to put order basically in this structure, to structure it, to order it, and to give it rhythm. Now when you visit at ground level, you don't see all this, of course. You're not aware of all this, but this is supposed to be, nevertheless, what the architects must do to, embed auspiciousness, and in this case, of course, sacredness in the case of temple architecture, in the structure. Now, if you look at the same, I have turned this plan 90 degrees, and if you follow the journey from the entrance, which is the Gopuram, this section symbolizes the outer world. Up to this point, you're still in the outer world, because anything can take place here. As I said, discourses, cultural activities, sometimes in olden days, educational activities, also teaching used to often take place in temples. Temples were also very often learning centers. But then the inner journey is here. It begins at the Antarala and of course ends with the Garbhagriha. So what you are doing basically when you visit a temple, this is very clear in such incidentally, this is one of the very, very few temples in South India which was built at one go according to a defined plan. All the other temples which you may visit at Madurai, Rameshwaram, they are a little messier when you look at the plan, for the simple reason that every dynasty kept, so you had the Cholas and sometimes the Pandyas, and sometimes you have the Vijayanagar Empire, and you have the Naik rulers and so on, and everyone wants to add some mandapam, some sanctuary, to get some glory in future. So then that's why you get very complex plans which are not so neat as this one. So this is basically the journey, the horizontal journey, where the vertical is something cosmic, and the horizontal is a journey from our outer being to our inner being, symbolized by the Garbhagriha. So this is very briefly, and maybe from my, I don't know whether traditional architects would agree, but this is, to my perception, the philosophy behind, the main elements of philosophy behind temple architecture. But then there are certain technical devices. And one of the most important, and this is why I call it sacred geometry, is the repetition of a motif. There are patterns, and ancient Indians were extremely attentive of patterns. They wanted patterns to be there always. So the pattern here is that every structure which you see here is actually a miniature temple. So you have the temple itself. This is actually the Virupaksha temple in Hampi. You have the temple, but it is composed of elements, and every element is basically equivalent to the whole. So this repetition of a motif is an impressive device which can be found at many levels. This is the Khandariya Mahadev temple of Khajuraho. There are many temples at Khajuraho. This is one of the largest. And you can see now this same repetition, but in another dimension. You see all of these structures, all of which correspond to some mandapa below. All of these structures are basically nothing but a repetition, but increasing repetition, which leads us to the complete shikhar, the tower above the Garbhagriha. So there is a kind of amplification which takes place in many ways. This is of course a sketch to show you. This is the same temple, in fact, seen from profile, and this is what creates a sense of successive dimensions, amplification of. This one is from Cambodia. The same principle traveled out of India. This is what is known as recursion or repetition of a pattern. It takes other shapes. For example, here you have these magnificent corridors at the Rameshwaram temple in South India, where you have hundreds, actually thousands of pillars, which give you this kind of sense of a rhythm. You see, something is happening when you look at it this way. There is it takes you into another dimension. This is actually the goal. But you can also find it outside on the very architecture of the shikharas. In this, for example, ancient temple of Mukteshwar in Bhubaneswar, which is 9th century AD. 9th century AD, you have also this constant repetition of a pattern all the way to the top of the shikhara. So these are some of the devices which are used. And but then there are other things going on which are very interesting, and which are the way these plans are actually evolved. And they are evolved through a method. All of these plans, they are evolved through a method which mathematically is called fractals. What are fractals? Fractals are structures that repeat themselves on any scale. So, for example, a snowflake. If you look at a snowflake and you look at a small segment of the snowflake, you find the same structures which you had detected when you look at the total snowflake. Mathematicians use fractals, for example, for coastal areas of, when you draw maps. Coastal areas often have fractal designs. So fractals exist in nature, but of course they are not mathematical in the full sense, because they have to stop somewhere. You can't go all the way to the atom or all the way to the universe. In mathematics there is no such limit. But then there have been several studies of fractals in Hindu temples. This is one of them, which interestingly has been made by 3 Koreans. But there are several more, a few by Indians, where actually you start from a basic simple structure and you add a part of it. A part of it is added on both sides, and you keep adding, you keep filling all the gaps with a part of this original structure, and you end up having ultimately stepwise this which is actually a fractal structure. And this is actually the top, this is the shikhara at the same Khajuraho temple seen from top. This is at the end of it what it looks like. But you see how it has been formed from the out of the simple structure, square structure, which represents the center of the Garbhagriha. So this is a very elaborate technique. The texts are not explicit on all the procedures of construction, and there's a lot of oral knowledge which is not put in writing, but some of the texts do allude to this constant amplification of a particular motif. This is the same shikhara. This is the same shikhara, but looked at, you see, after the addition of the side, the intermediary structures here. So these are recent studies, in fact, and it's interesting that we can always look at ancient technologies with fresh eyes. This is in fact a part of the ceiling. I'm sorry, it's a bit hazy. You may not be able to spot easily this motif, which is reproduced here at the end, but it's the same thing. It starts from one central motif, which is here, and you keep building up, just building up in exactly the method of mathematical fractals. So this is what many temples use to create a sense of rhythm, to create a sense of multiple dimensions, amplification, and so on. There are other important geometrical techniques at work, which is one of them is the technique of the mandala. That is to say, you don't start from just any plan. You are actually right from the beginning. You are placing your initial plan, especially the Garbhagriha, or in this case, the Borobudur stupa, which we visited last week, perhaps, in the largest stupa in the world, which is in Indonesia. And it's enormous. For those who did not see earlier, I mean, these people give you the scale, or these people here give you the scale. So it's enormous, but then it is, somebody did somebody called, excuse me, here, his name is Mark Long, did a detailed study, of very detailed, meticulous study of the stupa. First of all, he pointed to the same, and I want to show this because it's a Buddhist monument, it is not a Hindu monument, and yet it uses exactly the same cosmic philosophy. You have vertically the foot of this Mahapurusha, the body of it, and the head. So the same symbolism is at work, but in addition here, it is also spread out horizontally, because unlike a Hindu temple, there is no Garbhagriha, you can't enter a stupa, it is solid, there is nothing you can... So here the symbolism is repeated horizontally. But then what he found was that there were very complex mandalas. A mandala is a geometrical figure which can serve all kinds of purposes. You can use a mandala for pure art, pure paintings. You can use a mandala for if you want to do some black magic. Somebody was asking me earlier about black magic in ancient India. Well, mandalas can support magic if you're so keen. But mandalas are also used in architecture, and they are basically geometric pattern or grids which you will align your structure into. And then he shows how also this Mark Long, how actually the mandala is patterned also on the dimensions of the human body. So it's very interesting to trace all these connections. But in the classical Indian temples, Hindu temples, the mandala was not 19 by 19 as it is here. There were basically two mandalas at work, two sets of squares. One was 8 by 8 and the other was 9 by 9. Actually, in temple architecture, 8 by 8 is the one which is used most of the time. And 9 by 9 is more for domestic structures. Let me just show you some plans of Hindu temples. These are completely from Cambodia. So you can see actually something which is very familiar to us. This is Angkor Wat. This one, so highly geometric, and it is obviously based on a clearly defined mandala, is Nom Bageng. I'm sorry, I can't pronounce correctly, but it is on top of a mountain from which you can see Angkor Wat temple, though it was actually built earlier, not after. So you can admire the geometric layout. And this one, also in Cambodia, is remarkable for its multiple enclosures. Multiple enclosures is something that, well, we see it at Dholavira and we see it in many structures. This is also part of the recursion. You see the rate, you keep iterating, and you start from a central structure and you keep building further and further enclosures. Now a few plans from India. Well, top right is the same Ellora Kailash temple I showed you at the start. So it's a little more complicated, but there is a mandala at work for the center, the central part of it. But it's a bit more complicated because they had to fit this in the mountains. So there are some irregularities compared to the traditional temples. If you look at the one here, this is from Ranakpur. It is a Jain temple. It's a temple to Adinath, and you can see therefore that they follow again the same geometric principles as Hindu temples. There's basically no difference. And again, there's a very complex mandala artwork, a grid. And this one is actually the Vishveshwara temple or Vishwanath temple at Varanasi. And this sketch is drawn by James Prinsep, who was a very famous British Indologist, because he's the one who deciphered Brahmi. Before Prinsep, nobody could read Brahmi inscriptions. So he's the one who first published the edicts of Ashoka, for example. And, and actually, this is the original Vishwanath temple on which Aurangzeb built his mosque. And he has shown here in dotted lines, he has shown the existing contour of the mosque. So the mosque is here, but he drew the temple. And of course, the mandala here is very obvious. We can see 3 by 3. So this is going to be a 9 by 9 structure, basically. And this is his own sketch of the mosque with the temple beneath. Now, when we move to what is supposedly called secular architecture, this is a technical term which a lot of scholars use. What they mean by this is simply non-religious structures which do not follow strictly a religious purpose. There we find that actually a lot of very similar principles are at work. And this is the famous Vastu Purusha. But now this Vastu Purusha is not vertical as in the temple. He has been projected on the floor, the ground map, the ground's plan. And well, there are lots of legends explaining that he's a demon who has been contained in the structure, and we must be very careful, not to antagonize him. So, for example, in traditional houses, and this is the case, for example, in South India, both Tamil Nadu, Kerala, but also parts of North India, you have actually a fairly squarish house with a central veranda. And one of the principles of Vastu, I'm talking about the original Vastu, not what goes by the name of Vastu today, which is very different, or somewhat different. But in the old Vastu, you should always keep the center free, because this is the vital center. You see where the vital energy here is. So if you obstruct it, your whole building will be most inauspicious. And then, of course, this is going to be the northeast dimension. The head actually is here now. This is rotated slightly. You can see the head. So northeast is knowledge. The feet are where you should, in your house. This is southwest, where you should keep heavy stuff, like a storeroom or a master bedroom. Whatever is heavy should be at the southwest, south. So every corner, every segment, in fact, goes to a particular god or goddess, with Brahma at the center. So this is, and then the ground plan here is 9 by 1, 9 by 9. You can see the 9 squares, and every one of the 81 resulting squares is attributed to a particular god or goddess. And there are variations. It's not that this is always like this. Depending on which ancient text you consult, there are variations also between North and South India. So it's not as if it is, cast in stone or in brick. In fact, in the course of time, there is an evolution. But no ancient text tells you, that you should have your bath facing this direction, or keep your car in that particular direction. That doesn't. This is modern Vastu, but it's quite different. I want to show this sketch with the late Professor Bala Subramaniam of IIT Kanpur, made when actually I pointed out to him all these ratios at work in the Harappan world, and he said, but look, the Delhi iron pillar, which he studied so well, as you know, and there's a replica here on the campus. I think it's half-size replica. If you look at the excavated, the portion over the ground, this is the ground level, compared to the total length, you get the same 5:4. So this is supposedly a secular structure, but this ratio comes again. And then we can see entire cities, of course few. I showed the other day some very striking city of Shishupalgarh near Bhubaneswar with this rigorously square plan. This is Jaipur. This is Jaipur, where we can see the same set of 1, 2, 3, 1, 2, 3, 1, 2, 3 squares, except that the hill here, you see, this is where you see that Indians can always adjust and are always, accommodative. The hill was obstructing, so this square was actually transferred here, which is not rigorously according to the text, but never mind. This is a city which is planned according to Vastu. And so it shows you that these principles actually were running across so-called sacred or religious architecture and so-called secular architecture. As always, the border lines were very hazy. I want to draw your attention to the title of Jai Singh. Of course, you know Hindi better than I do, and this means 1.25, right? Sawai means 1.25, and Sawaya, I'm told, is the way you can make offerings in some temple when you offer 1.25 kilo of rice rather than 1 kilo of rice. So we find the same 1.25. Why should a Maharaja call himself 1.25 Jai Singh? And the answer is obvious again. This is an auspicious proportion, and he's basically telling us, that he exceeds his predecessor by, there has to be an increase always. There has to be an increase. So 25% better than his predecessor, which is relatively modest as a claim, but you see, this is the philosophy which we can trace all the way from Harappan proportions. Let me end with something rather different, but which still has to do with embedding something unusual in a landscape. This is a work done, and I could give many more examples, but by an American astrophysicist. His name is John McKim-Melville, and he has worked a lot in India. He's an expert on what is known as archaeoastronomy. So he studied the ancient astronomy of many ancient civilizations, and again trying to discern patterns, alignments. And in fact, I didn't have time, but I could have pointed out that many temples follow cardinal directions. Sometimes you have pillar alignments pointing to, for typically the sunrise on 21st June, on the solstice, sometimes the equinox. So there are astronomical concepts embedded in temples that we could have expected. But what is much more unexpected is that in many cities he has explored Hampi, he explored Chitrakoot, he explored 2-3 more, and he explored Varanasi. And in Varanasi, he found that this is a city, of course, dedicated to the worship of the sun, and especially in the form of the 14 Aditya. Adityas are Vedic deities, which are basically solar gods. And he wanted to see how these were distributed on the landscape. And this is something which actually, local citizens had never, modern inhabitants had never bothered about. This was not part of their traditions, not part of what they remembered about the city. So they took some 2 or 3 weeks to first of all locate all these shrines, because some of them actually are not at all big temples. They are small shrines, and some are really tiny, a small niche embedded in a wall. So it took time. They had to work with a lot of senior pundits, and finally they could map the whole thing. And when they mapped it, they found something astonishing. They found that from one shrine, if you draw lines to all the others, you have exactly, they point to the sunrise every Hindu month, starting from Makar Sankranti here, 14th January. This goes below to 14th December, 14th November, 14th October, and above it moves towards February, March, April, May, June. So, and it ends at the equinox, you see, 21st June. So there is something there is something, no, rather it ends in 14th July, sorry. There is something quite astonishing, which is, and this is a lost tradition. That's what is very interesting to me. It's because it shows you how sometimes modern investigations can actually rediscover lost traditions. This is something no Pandit in Varanasi remembered or knew about. That this whole city was actually designed as a kind of sundial, if you like. It's a sundial. The whole city is a calendar. The whole map is a calendar. You see, so this is quite astonishing, and it is another way, yet another way of bringing the cosmos into the geography, into structures, into basically, in this case, into a whole city. So there is a desire in the ancient Indian, and not just the ancient Indian. You could do a parallel lecture probably looking at ancient Egypt. Typically, there is a desire to be always united to the cosmos in some way. And these are, I have just shown you briefly some of the devices that are used to embed these concepts of cosmology, sacred geometry, sacred ratios. So coming back to the Harappan times, I cannot of course swear that these proportions had a sacred meaning to the Harappans because they don't explain, but obviously they were important because they kept applying them repeatedly, site after site after site. So this is the idea. I think I've explained sufficiently, to have build equivalences between our micro level to the macro level and to the universe. And of course, it's not only auspiciousness, but it's beauty that is a major concern of architectural practices. So this is a very brief overview of Indian architecture from a slightly unusual point of view, where I wanted to show you those concepts at work and some of the geometry that goes into the building of these very complex structures. Thank you.